Hello, my name is Shannon Kuehn, and yes, it's pronounced Keen. I am a senior program manager at Microsoft. In my role, I spend a lot of time demystifying parts of Azure. And today, I'm here to talk to you about infrastructure as code for complete beginners. If you feel so inclined, definitely connect with me on LinkedIn or Twitter. I tend to post a lot of good content, and I'm around if you've got any questions. So my DMs are always open. You can always send me a message on LinkedIn as well. I'll try to connect you with people that might be able to help as you try and understand more about the Azure cloud. So, infrastructure setup. How did it start? I'm sure folks who are watching this might have a little bit of anxiety if you look at the left hand side of the screen. In fact, one of these environments was one of my environments. So it's always interesting to think about where we came from. In the way, way back machine, we were building out one app or one workload per server. Everything was physical, right? So physical servers, physical switches, physical power supplies, even the desktops that we would provision for our end users were physical, right? It was very manual. You would rack a server, you would connect all cables, you would install the OS, and you would apply all of the updates, which did take quite a bit of time. Then you would join a domain, and it would all be very manual, right? And then if you needed to, you would set up agents to make sure that your environment was managed and maintained. So that worked, but it did take a lot of time, and it wasn't really streamlined. So then I guess where did it go next? Well, if we think about the evolution of infrastructure, we then moved into the realm of virtualization. That really gave us a lot of interesting new ways to think about workloads. So instead of having all of these physical servers, one app per server or one workload per server, we could have a physical server act as a host. So then we had this whole notion of virtual machines where you could run multiple servers on one server. So there's a lot of great consolidation. Of course, there was also virtual machine sprawl as well, because we had the capacity to add more than we had before. So we had a bunch of VMware environments, Hyper-V environments. We were able to start thinking about speeding up the process to bring about a workload online, right? We were able to start templatizing environments. So if your servers needed to have a series of agents installed, a series of software configurations made prior to the server being online and live in production, you could think about building out templates. This also allowed us to spend less time racking and stacking servers, right? We could start thinking about bringing in automation. So we started to script out the domain join and the agent step, right? So then we weren't spending all of this time making sure everything was connected correctly, the manual install of the OS, the applying of all the updates, et cetera, right? So things got a little bit better, but we could probably be better than that, right? Now we're in the world of cloud. Cloud is everywhere. Regardless of if you are 100% in the cloud or you're just trying to think about how do I embrace the cloud, cloud is there and cloud's here to stay. So the idea here is we have templates. Now there are templates in the Azure realm, there are templates in the AWS realm, the GCP realm. It doesn't really matter where you find yourself related to the cloud choice that you make. I'll talk a lot about Azure just because that's the realm that I am very familiar with. So these are declarative templates. And what do I mean by declarative? Well, you are describing the end state of the process. So you don't care the steps that the REST endpoints make in terms of building an environment. You just say that you want a web app, you want a SQL backend, right? Azure will take care of the rest. So you have parameters, and those are the pieces that tend to change so that you can take those templates and deploy it in multiple different environments. So you've got a template for prod, you've got a template for staging, you've got a template for dev, for test, etc. This starts to help you with infrastructure build out because you're not having to manually click through any of the GUIs. So the inputs are processed at runtime. So it'll take a look at the full template. It'll figure out a way to go through and add the infrastructure in parallel. So that speeds up the process quite a bit. And the environment is fully configured once the template runs. So you've got a lot of different realities. This starts to open up the door related to the speed at which you can build environments. This also allows for collaborative development. So you've got your main template, which might be a very large template, and you've got your child templates. So you've got teams now working together. You don't have to sit in a siloed world. You can actually build these environments out, and so that this main template won't kick off certain components until other parts are built meaning the child template runs. So it's a really interesting paradigm that we're at, right? And that's where we've got infrastructure as code. So, what does infrastructure as code mean? Now, the Wikipedia definition's to the right on this screen here, and I'll read it real quick. Infrastructure as code is the process of managing and provisioning computer data centers through machine readable definition files, rather than physical hardware configuration or interactive configuration tools. The definitions may be stored in a version control system. Seems pretty straightforward, right? The idea here is that you're building environments programmatically through code, you're building them out in a declarative state, you want them to show up at the end fully configured. Seems to be an awesome reality. Of course, if you were like me, I initially had a little bit of anxiety thinking about the fact that I was turning from a GUI based driven deployment to a software based and software defined deployment. So, when we think about this, what is infrastructure as code or infrastructure from code? So, it's an approach to infrastructure automation based on software development practices, right? So, those software devs that we never used to like, we're now starting to feel like them, right? And this is an opportunity for you to have that conversation. You're now dealing in the realm of building out templates and you're having to look at lines of code. I have learned so much from the development colleagues of mine, the ones that had spent all of this time developing applications over the course of their technical career. So it's been a really interesting journey trying to get to this point. So infrastructure as code, or IAC, as you'll see it abbreviated in the wild, it emphasizes consistent and repeatable routines. Like I had mentioned earlier, you'll have a template for dev, you'll have a template for test, for prod, for product, or for you'll have a template for test, dev, prod, maybe even staging. So you don't have to worry as much about the ways in which the environment gets provisioned because that template can be used across a number of different environments. So this allows for fast provisioning and quick system changes plus configuration. So gone are the days of having to go into a server, run an executable, and have it then link up to where it needs to link up and report correctly. You can start building that out in the actual template so that when the server comes online inside of Azure or your cloud of choice, it's got everything fully configured. So changes are made to definition files and then rolled out to systems through automatic and unattended processes that include testing and validation. So I've worked with a lot of customers who spend a lot of time getting more comfortable with this inside of the test and the dev environments. So your folks who aren't super familiar with how they code environments, go beat up your dev and your test environments, right? Those are great opportunities to make sure that everything's working as expected. And that's an awesome spot too to bring that collaboration into the mix. Maybe there's a development person that can come in and sort of help lead the way. Because often I feel this is where DevOps comes into the mix. And when you think about DevOps, it's the joining of development and operations processes. So it's a great, interesting synchronization between those two realms that hadn't been there prior. It's really people, process, and technology, right? Technology is the cool part, but it brings about different sides of the business being able to work together. So infrastructure as code is a descriptive model. It's a software defined deployment, right? You're not having to go into a server, you're not having to RDP or SSH in and run a series of bash scripts or run a manual install or run a PowerShell script, right? You can build that into your template. That way it's less of the maintenance and care after the fact so that your servers and your environments are ready to go. It's also software defined management as well, right? So you don't have to think about the fact that you'd have to go and manually do anything. You can control a lot of those builds programmatically via a template. And so that starts to alleviate the burden of having to go into a server and make sure certain things are configured. Now, infrastructure as code, the roots stem from software development, and it shouldn't make you feel anxious. And I say that with a heavy caveat. I think the more you get exposed to infrastructure as code, the less anxious you'll feel. In fact, I've got another session on the brand new template language that Microsoft is using now for software-based infrastructure as code deployments. It's a lot easier than it used to be. And you almost never have to start from scratch, but know that the realm of starting from software development or stemming from software development starts to help this process along in the sense that we don't have to worry the same way anymore about having manual configurations and configuration drift as environments continue to function in production. So this also allows for flexible infrastructure build out as well. So you don't have to think about having things be managed individually. You could have your server set managed as a fleet of servers, which starts to sound really appealing, especially given the fact that where we came from, it was very manual. Something broke on a server. You had to go pick apart what got installed, when it got installed, who was on that server, right? If you build out your environment in this particular manner, things start to feel a little bit more straightforward, and you don't have to worry as much about these individual machines becoming a problem. So the value proposition here is pretty important, right? There's the faster execution. So you can build environments and tear them down pretty readily. You can experiment quite a bit as well. This then leads to the reduced costs and the reduced risk. So by the time the environment reaches production, you probably have gone through and you have tested quite a bit, right? You don't have to worry as much about this environment being live in production because you've learned from building it in the lower level environments what needs to happen for it to be resilient, for it to be online and ready to go at all times. You can manage your infrastructure via source control as well, right? So, along with backing up and replicating servers, you could have entire workloads or entire environments built into templates. So that if you've got a fleet of 4 or 5 servers and let's say something happens, you could always restore from a backup, right? And I'm not saying that backups aren't important, right? Backups and then replicating your environment. But if you needed to stand those VMs up very quickly, you could. So if there's not a lot of info on those servers that is not as important, meaning if it's not doing a lot of holding state steady on that machine, you could always spin that server up as another way to protect your environment. And then it's also the notion of increased collaboration, right? So you don't have to worry as much about the silos that exist. And in working with enterprises over the course of my career, I've always seen quite a bit of customers tend to live in that siloed realm too much. So there's a lot of stalled projects because security won't talk to the infrastructure team, right? Or the development teams won't talk to the core central IT teams. So there's this opportunity to collaborate, and that speeds up the process in terms of moving you forward for your digital transformation. So, what does all of this really mean? Well, I think at this point, you probably start to understand that we want to manage our infrastructure through configuration files and templates throughout their life cycle, the same approach we take to software development, right? So, software developers really have led the way in the opportunities for them to change code, adjust code, build out applications. And this is an awesome opportunity for us as operations folks to start thinking about moving towards this realm. Just because of the fact that I feel as though this speeds up so much. We're not having to do the manual configurations. We're not having to worry about what's on server A, what's on server B, what's on server C, right? They should all be very similar, especially if they're part of the same workload. So this starts to make things a little bit easier related to managing and maintaining the environment. And when you're moving to a software defined world, you're not racking and stacking servers anymore. So it's an awesome opportunity to embrace code and to figure out how to get sort of started. So when I talk a little bit about declarative and imperative deployments, I always use this example. At the very top, we've got imperative code. And at the very bottom, we've got declarative. So what's the difference? And you'll probably hear this quite a bit as you embrace more code. The imperative side is where we don't want to necessarily wind up. And there's a slight caveat there. If you are comfortable with PowerShell, automation and any automation is better than no automation, right? But the challenge I would start to state is you should probably move towards declarative. So declarative would be like you calling a friend and saying, fix my car. You don't care how your friend fixes your car, it just won't run. So declarative, again, is that end state, whereas imperative would be like, I don't know, you calling your dad and asking how to fix your car, and he gives you a step-by-step, play-by-play on how to fix the car. So really, even though it looks like it's more code, the declarative code is the easier way to process things in terms of speeding up deployment. But again, if you have no automation, PowerShell or Bash scripts or anything of that sort, it's better than nothing. But the challenge would be to move towards a more declarative model. When we think about version control, we would like to store these files in source control. So we need a way to manage that. And it's the same tools the development folks will be using, right? So Azure DevOps, the Git components of Azure DevOps, the Azure DevOps server, GitHub, those are the ones that hang out in Microsoft's realm. There's also things like Bitbucket, right? Anything is better than nothing, right? You don't want to have these source control files living on a server in a file share somewhere. It's not a great spot, especially if you're trying to offer up more collaboration. So putting these template files in source control is invaluable. So where do we write this code? Well, there's a couple of different tools that we tend to talk about at Microsoft. There's Visual Studio Code, which is free. It's a lightweight install, and it runs on Macs, it runs on Linux, and it runs on Windows. So it's pretty well spread across multiple environments. And then there's a great plugin library and extension library. So that helps, right? You get some of the IntelliSense, which IntelliSense is, it's basically a helper. It helps you programmatically build out your template if you can't find specific code online on how to build a load balancer. Let's just say that you can't find that for some reason. The IntelliSense would help. And you get that by way of the plugins. Then there's Visual Studio. Now, Visual Studio is a heavier install. It's a full development IDE. So it's a full development environment. It's mostly designed for .NET developers. But if you've got access to it, there's a lot of great ways to interact with ARM templates through Visual Studio. There's a lot of built-in tools. And I think that's the piece that's also exciting if you're brand new to infrastructure as code. But it is a heavyweight application, and it does take up quite a bit of space on your machine. So make sure that you kind of know what you're going up against if you're thinking about Visual Studio versus Visual Studio Code. There's also the Azure portal, right? It's all online. There's no install, and there's no IntelliSense. So it's better than nothing, and it's probably the easiest to kind of get started. But I think a lot of folks are gravitating towards Visual Studio Code. Now, if there's an IDE that you prefer that doesn't show up on the slide, that's also valid. So Atom's one that I've heard of customers using pretty regularly. I even used to work with somebody who used Notepad++. So long as you've got an IDE or some sort of tool that can sort of build out your code or help you build out your code, it's better than putting it into Notepad, for existence, or for example. So the templates themselves offer up power of repeatability. So Azure templates can ensure item potency. Now, what does item potency mean? Well, think about item potency like this. You want to potentially build out an environment. Let's say you've got a template build that's got two servers that need to talk to each other. Let's say the first build, the first server spins up correctly. The second server doesn't. So you've got to troubleshoot. You've got to rewrite parts of that template, and you've got to redeploy it. Each time you redeploy it, it's not redeploying multiple additional servers. It's redeploying the same environment, or at least skipping parts of it, because it's smart enough to realize that those environments already exist. So it's not going to duplicate the process. It's not going to add a bunch of additional extra features. It's going to keep things very straightforward in the sense that each time you deploy it, it's going to be the same environment. The templates simplify orchestration. So if you need to have certain components installed, you can always build that into a template. Then you've got the capacity to roll things back too, right? So if everything's software defined, rolling back anything that didn't work correctly is pretty straightforward and easy. Then you've got the idea of templates provide cross-resource configuration and update support. So you can grab different components from different environments and sort of lump it all together into whatever you're trying to build. So the templates themselves, they are source file, they are checked in, and they're put into version control. They will specify resources and dependencies. So another thing to pay attention to as well, I know I talked about declarative versus imperative. Let's say you've got something in your template that needs to be matched up in a specific order. Let's say you've got a VM that you're building in Azure. You can't build a VM in Azure unless you have the NIC available first. So you can specify dependencies in the templates as well. That will sort of guide the declarative nature of that template and have the ARM endpoints provision the environment correctly. And then the parameterized input and output is also an interesting realm too. So that's what helps you in terms of taking that template from one environment to another environment. You will only be changing your parameters. Everything else should probably stay the same unless you need to add in a new API or unless you need to change your resource around that you're declaring. So every process can be improved. Now, on the left here, this is the Formula One pit stop, and this is from 1950. And on the right, it's the Formula One pit stop in modern times, and I believe that's from 2013. So I want to show a quick video because this has always been a helpful thing for me to realize why process improvement's important. So it starts out and it sets the stage. So we're looking at the Indianapolis 500 in 1950. The car's pulling up, and there's only a couple of guys working on the car, right? And it seems to be a little single-threaded. You've got the one guy trying to remove the tire to put the other tire on that's laying down. They're adjusting certain components on the car. But you've got a bunch of guys sitting around watching this process too, right? So there doesn't seem to be a good use of everybody's time. But again, it's sort of single-threaded. This is where we were back then. We hadn't really thought about how do we make this better. And so I want you to pay attention to the amount of time it takes to get this car ready to go so that it can go back into the race and continue. It's literally a little over a minute. I think it's 1 minute and 10 seconds. And so as you see, the guy's putting on the other tire right now. I mean, it's kind of a long, involved process, right? It's not a fast reality, unfortunately. But the car is ready to go, or it's very, very close. And then 1 minute and 10-ish seconds later, the car's back on the race field. It's back in the race. Then we've got 2013. So look at how many more folks are involved in this scenario. And we've sort of built out certain roles for certain people. The bulk of this video is waiting for the car to pull in. So once the car pulls in, I want you to notice how fast they are able to get the car ready to go back into the race. It's ready to go. I feel like that is a fantastic process improvement. And I think the big piece to take away here is that even though infrastructure as code feels a little bit scary, it will speed up the process. Because the idea here is this is what helps you get to that spot of transforming your environment, speeding up innovation so that you can bring things online quicker and they can be more resilient. And so it seems like it's a lot of extra people, but you get a much faster result and you don't have to wait as much for the single-threaded motions of building out an environment. So that brings me to the end of what I have prepared to talk about today. And I hope that you have determined, or at least decided, that maybe what makes sense is to start embracing infrastructure as code. Feel free to connect with me on Twitter or LinkedIn if you've got additional questions. And thanks to the folks that have hosted Define Tomorrow. This is a great opportunity.